Hello everyone, I am from group 2. We are demonstrating our PV panel characterization for larger PV panel. In our previous video, we have done PV panel characterization for smaller PV panel. Here we have Arduino Uno that will use for data characterization and data processing purposes, and we have connected this with COM5. Here we have voltage sensor that will measure the voltage. This can measure up to 25 volts, so we have used it both in the smaller PV panel and also in the larger PV panel. Here we have ceramic resistance. Why we have taken ceramic resistance? Because it has a high power taking capability. The resistance value that we have taken is 1, 5, 10, 12, 16 and 100 ohm. We have taken 6 points, and by sampling we will take by switching MOSFET gates over and over, we can take up to 64 sample data. We will use as a switch, we will use MOSFET as a switching gate. Like before, this MOSFET is different because we have a high power rating that is applied here. Here we have a PV panel that we have taken from WEIGHT laboratory. This PV panel has a rating of 20 volt and up to 2 ampere. It can provide us. So as the circuit can provide us up to 2 ampere, we have taken the wire that has a rating of 5 ampere and also a current sensor that can measure up to 25 ampere, ACS 712. So and thus this is our experimental apparatus. We have used one breadboard, and then this project works. Now we'll go to the data visualizing section. Part, we find that we have the code is similar to what we have seen for smaller PV panel. Here we have taken COM5 with a baud rate of 9600, and then we find that we have taken zeros as a, we have initialized the array of the voltage, current, power and power data set, and we have taken sampled the data from Arduino that we get, and then obviously there is a synchronization of Arduino and MATLAB going on here. And then after we have taken the dataset, we have built the dataset, and then we do post processing. So we do the analyzing. We are currently conducting this experiment at noon 12, so obviously we are getting full illumination and ingredients to find the best dataset. So after this processing was done, we will find the PV curve, and also we will find the IV curve. Yeah, now coming to the result section, we find that the IV curve matches with what we have seen in our theoretical study. We find that the current IV curve matching with that, and also the PV curve matching with that. Now going to the MPP section, well, like the maximum power point section, we find and after post processing, we find the series, shunt resistance, maximum power, ISC, VOC, and field factor. Obviously, we are getting obviously the data sets are close to what we find in our PV module data set that we received from WEIGHT. Part here, we have taken the data of this log, and we have selected the base data set, that is panel data.mat, and from the data we will show our IV curve, then we will show our PV curve, and then by differentiating we'll find our series resistance and shunt resistance, and from MPP we will discover our maximum power point, and then we will find the field factor and via MPP and IMP. So now running this section, we find that we have a IV curve that is similar to what we have seen in the day of experiment, and we have, for further analyzing, we find that the series resistance, charge resistance, maximum power, maximum current, voltage maximum, ISC maximum, and VOC, we find all of them to be matching closely with the nameplate dataset that we received from our lab. Thank you. This is done for larger PV panel.